Okay, well, hello guys. So I'm going to give you some introduction to the functional API, and I think it would be good for you now that you know the sequential API to also have an idea of the functional API because as you go more advanced, you will tend to basically lean toward using the functional API. Hence, I think it's a good idea for you to have an understanding of it. Okay, so the Keras functional API, it's a way to create models that are more flexible. Okay, so comparing to the sequential API, it basically, this functional API enables you to handle models with non-direct topology, yeah, or like models that can have shared layers or even multiple inputs and outputs. Okay, so. Mm, as such, you can just summarize it in the model being more flexible. Okay. So the main idea is that the deep learning models usually, you know, follow you know, a certain directed method of layers being stacked one after another, yeah. And the functional API is, in a sense, building of these graph layers, okay, um, precisely with, the flexibility that you want it, to be. So, like previously we had or a sequential model, we created a sequential, sort of environment. And in that sequential, we added dense layers. Okay, we added, I don't know, count 2 layers, whatever. But you couldn't add, like dense layers running in parallel or different inputs coming into that. Yeah, you couldn't graph it like that. But with the functional API, you can. So let's start playing. Yeah. So let's build a model using that functional API. So I'm going to start with, I'm going just to import Keras. So import numpy as NP and import Keras. Of course, I can always, like you can also say import from 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 TensorFlow.keras import layers. Yeah, okay. So we got everything that is imported. Yeah. Now we're gonna start building our neural network model. For example, we're saying input. What do we give to our data always? We give an input. Yeah. So we're gonna say input. Actually, let's put inputs because input is already a function equals Keras dot input. Okay, so I'm creating an input layer here, and when I create an input layer I need to give a shape. Yeah, so shape equals, let's say we just want to give it a vector of 784. Okay, so let's just do that. Okay, so this is an input layer we just created. So we have imported Keras, we have imported layers, and then we're calling the input, yeah, from the Keras directly. So if I was to say inputs, let's say TensorFlow shape dtype created by layer, okay, it's just the input taker. Okay, now here we have a shape. The shape is 784, sort of dimensional vector, yeah, and it's just a single vector. Remember that when we put, you remember like in the shapes, yeah. So in tensors we have the shape of tensors. So shape of tensors. Remember we have batch, row, call, and channel technically, yeah. Okay. When you are defining when you're defining the input, you don't give the batch, yeah. So if your data is a single sort of vector, one-dimensional vector, you give the rows. But if it's rows and columns, you give that. Or if you have rows and columns on a channel, like color images, you give that. But you don't have to you don't give the batch sort of value, when you're defining the input shape. Just be aware of that. So I'm going to say, do not give the batch number when defining the inputs. Okay, so that's just the. Now, for example, let's say we have an image of, I don't know, let's say 28 by 28, a color image. Yeah, that's what you're feeding. So obviously you would have a batch also. Imagine your image is 28 by 28 by 3. And let's just give a batch number to it, like 50 of these images. Yeah, just imagine. So if this is the case, the way you do it is that you're going to create inputs equals keras dot inputs, and then shape equals, I'm not going to put the 50, but I'm going to put 28, and 3. So that's what it basically means, like, what did I do wrong? Oops. Yeah, so I don't put the batch number basically in there. It's very important that you know that. And so that input at the moment contains information about the shape and the type of the input data that you're feeding. Yeah. So these inputs at the moment, if I say input dot shape, you see, we have already, it is created, to be taking this form of shape in place, basically. Yeah. So as I said, the input that is returned contains information about the shape and the type of the input data that we are going to feed into it. So I would also, if I say inputs dot dtype, you see, everything is preset now. It's assuming, that it has information regarding what it will be accepting to be fed into it. Okay, so now that we know this, we are going to create a new node in the graph of the layer by, sort of calling these inputs and, like objects. So let's go and say we want to add like 64 neurons in there. So from layers, yeah, you remember dense basically? So we are going to create the input. We have done that, yeah. And if we say dense equals layers dot dense 64 activation equals value. Okay, did I do this right? I think, yeah, that's fine. Name they are layer LAYRS. Okay, so we are basically creating a new node in the graph of layers by calling a layer on the input object. Okay, so we have already an input in there. Okay, now I've just created a dense layer. Okay, that's my dense. Then I'm going to start by saying x equals dense, and what I'm going to put here, I'm going to put inputs. Okay, now I've created an input layer that is feeding into the model. Then I'm adding a layer of 64 neurons with a ReLU activation function. Okay, now it's like as if this is my first layer. Yeah, this is my first layer. You know, like with the sequential model, the way you were building it, you were not creating the inputs yourself. So first we went and looked after our input. Now it's like we are creating a dense layer. So I'm saying x equals dense, and I'm feeding it inputs. Except that from this point onward, things are going to change significantly. Now look at this. I'm going to add another layer of 64 neurons. And the way I do it is going to be x equals layers dot dense 64 activation equals value. Okay? But guess what? Guess what? Guess what? Then I'll have to do that. Okay? Now, I know this looks a bit different to everything else you have seen in Python on functions, yeah? But to better sort of, put these all together, so this is how things are building up. Okay. I'll just create it. Okay. So in other words, I created my input layer. I have a dense layer that I've defined. So x equals dense inputs. Okay. So this input is now being fed into this dense, and the output is called x. Now this output x is being fed into this layer.dense function or layer, and the output is going to be called x. So think of it going like this way, yeah? Now, then we are going to create an output now, okay? So shall we just do another layer as well? Okay, so I'm going to add another layer of 10 neurons. X equals layers dot dense. I'm going to put 30, so 24 neurons. Activation equals value. Okay, and guess what? I'm just going to put x here again. Yeah, so I'm feeding this x into the next layer. Well, okay, so now that's done as well. Now we're going to create an output. So we start with an input and you end it with an output. So output equals let's say this is a classification or regression problem. Let's just say it's a classification problem. So output equals, or shall we say outputs, because we put inputs, outputs equals layers dot dense, okay, layers dot dense, 10, okay, and what do we feed it? Again, that x, okay. Now that's done. Sorry, dense, then this isn't what we do it. Okay, so this is the model built. But of course, we have just defined the structure. We haven't basically put it together yet. Yeah. Now to put it together, it's important that you do this model or functional model equals. This is how you do it. Yeah. Keras dot model, and here you put input equals inputs and outputs equals outputs. Okay, and you give a name to it. Name equals LSPU cool students. Cool students functional API model. Okay, so our functional model is now made. Okay, now let's look at our model summary. Okay, so our functional model the summary or functional model dot summary. So we have an input layer of 28, 28, 3. We have a dense layer of 28, 28, 64. We have a dense layer of dense 5, 28, 28, 65. Dense layer 6, and the dense layer that is at the end. Yeah. So take a look at this and then compare it with what you have created basically here. Okay. Let me see. Just bear in mind that, for example, when you do something like that, you can like basically go and then cut your code short. But if at this stage something like that would confuse you, just stick to that. Okay. But otherwise, if you define dense to be this, then you can continue adding loads of dense layers, well, provided that that's a 64 neuron. Yeah. Otherwise, if you want it to be more sort of versatile and you want to just keep manipulating, you can go and just keep writing this and changing this number of neurons in there. All right, so now we have created this model. Okay, let's plot this. So let's see how does it look. So from keras.utils import plot model. Yes, yeah, and let's import that, and let's plot our model now. So we're gonna say plot model. We're gonna say plot model, and we're gonna give our model's name. What was our model's name? LSPU or functional model. Our functional model. There you go. So that sort of gives, you know, the shape of a model, basically. And if you want to sort of see the flow of shapes, you just add a parameter. You say show shapes. So show shapes equals true. There you go. So technically, gives you a graphical representation of this summary that you have here. Okay, and then you can also do. You want to different. I mean, like you can save it like this. I think copy image, and I think you can now paste it in Word. But let me see if I have a. No, need that. Let me just. Sorry, I'm using a different. So, like you can put it in the paint or somewhere and do manipulations with it, like trying to sort of, say, okay, like the red part is this. When you want to, create a presentation and say stuff about your model, so you can do that. Anyway, enough of that. Yeah, you could, I think, save it too. So if you go to plot model, let me just copy this. And then you just need to give a name, fun model dot jpg, I think. Is it dot paint? So if I run that, okay, we just see fun model. There you go. So you can have it as an image as well, basically. That. But anyway, that's okay. So this is like a very basic style of creating a TensorFlow functional API sort of deep learning model. Shall we now go and just make a little sort of experiment? So if I bring, like let's load the MNIST data from Keras, yeah. So you're just using this command to import this data. We have talked about this in the class, like you just importing data from Keras. So let's just see x train.shape x. So it's like a small x train.shape. Since my keyboard there is constantly giving me so 60,000 images, and they're 28 by 28, and x test dot shape x. I'll give a capital X anyway. Okay, which is that. Okay. Obviously, I mean, like our input data at the moment is not going to be, we are going to be basically, how do you say, we don't have any convolution steps or any, what do you say, like max pooling or nothing. This is just a neural network. It's not a CNN model at the moment. Okay. So if we want to like feed these images into this, okay, these are the MNIST data. We have to reshape it into vectors and then fit the model and the data, and then evaluate the model and sort of see how it runs. So if we change the x train and x test, so x train equals x train dot reshape, and it's going to be train is 60k, 60, yeah, 23, and it was 28 by 28, so code 28 by 28, 784. Okay, and if I just do this, just bear in mind for a second, let's just, before I do anything else, how about xtrain dot d type? No, yeah, unit 8. That's no good. Yeah, if you want to feed it into a neural network, that sort of data structure is not good. So we need to change the data type, and we're gonna do dot as type, and as type we're gonna go with np dot float dot 32. Okay, so if I say xtrain type start float 32, how about xtrain dot max, guys? 255, and that mean obviously 1. So why don't we just rescale it here as well? Okay, there we go. All right, so if I do max, it's 1, and min is of course 0. And if I do x dot d type, which is flow. Just one thing. Shall we restart this? And I want to show you something cool. Okay, just something cool. So we went back all the way, So D type, I restarted it, yeah. So everything is ignore all of this, yeah. Ignore all of this. Now, what if instead of doing this as type thingy, I'm just going to copy this here. Let me get rid of that thing. If I create a code here, just so imagine I haven't run this now, yeah. But I'm going to copy this. Okay, and instead of as type, I'm going to take this as type out. Okay, so look, at the moment, xtrain is just the original unit 8 type of data. And if I do this, yeah, just divide by, okay, so as I said about the data types, sorry about I think something went wrong with the computer. But anyway, so we are doing this with our xtrain and xtest, okay? So we have these two data, and it's now our data is basically ready to go. So finally we have our model. That's our model. Everything else is the same. So model dot compile, okay? Model dot compile, and then loss equals TensorFlow dot keras dot losses, and let's say it's a sparse categorical, isn't it? Sparse categorical cross entropy. Okay. And what else do we need to do? We need to define an optimizer. equals chars dot optimizers dot add-on, let's say, and then matrix equals accuracy. Accuracy. Okay. So model is not. Oh, what am I saying? We didn't name it my model. It was our functional model. Oh, sorry. Okay, so now our model is basically now well fit. So we're just going to say history equals model dot fit, of course, x train, y train. Sorry, what am I talking about? X train and y train, isn't it? Yeah. And batch size, yeah. Batch size. Batch size is going to be 50. Yeah. Let's just do that. Oh, why do I keep doing this? Sorry. Okay, what went wrong? Ah. So, why are we getting an error, guys? Do you think? Value error. Input 0 of layer LSView Cool Student Font API is incompatible with the layer expected this font shape of that. Okay. Font shape of this. This means the images that we are feeding it. Look at the image. What is the 50? 50. What is that's the batch size? Okay. Please pay careful attention. So while I'm fitting it, this batch size now is going on fitting into the image that is being fed. But then my X train X shape, and I mean we tested these before, yeah, which we basically did a reshape here. So what is wrong? It's saying that the input shape is incompatible. Shall we go back to our model and see what is wrong with our model? So dense equals that. Input shape. What is my model is set to accept as an input shape? Look at that. Yeah. So I'm going to do copy paste all of these. This is not a convolutional neural network layer, is it? It's a dense layer. And look at it. What am I taking as an input? I'm taking images. So how about this? We're going to say that as an input, we're going to take, okay? So we're going to say that as an input, we're going to take the 784 simple vector, okay? How about this now? But bear in mind, the moment I've done this, yeah, the moment I've done this, I need to redefine the model. So I can't just say this, I've done that and everything else is fine. No, I need to rerun all of this. So let's see how things change here. Okay. So now we are taking a single vector, okay? Is this changed? Yes, that is changed as well. And is this changed? Yep. All right. The data we don't need to change, is the same thing. They are all the same thing. So model, we need to compile this again. Yeah, we need to compile the model again. So model is compiled. Now let's try this. Yes. Okay. So we fitted our model, and let's just see. Why did it run once? Quickly tell me. Look at the parameter, the epochs. By default, it's one. Obviously, we want more epochs, isn't it? Now, I'm not going to run much more. Well, let's just make it at three. Okay. So the idea is, I mean, we have done this before in the other courses in the class, but I just wanted you to see that from one point onward, yeah, everything is the same as the sequential API, you know. Well, that's really about it. This is a very light touch on TensorFlow's functional API, which I hope you have enjoyed. Okay, so code along, and of course, at the moment, maybe you don't need to stress too much about this, but I thought like it would be good if you become familiar with it. Okie doke, thank you.